pharmaceuticals requires those ultra-low temperatures to prevent the denaturing of the mRNA and other proteins that make the vaccine work. In the effort to achieve such low temperatures, there's an alternative to fluorinated gases that you might be familiar with. It's called dry ice. It's solid carbon dioxide that sublimates, means turning into a gas, in a humidity-free gas around negative 80 degrees Celsius, which is great. But since that gas is the same carbon dioxide that's responsible for climate change, using dry ice is not a very sustainable solution for ultra-low storage, as effective as it is. Reefers are refrigerated shipping containers that can be stacked on ships, trains, or loaded on a tractor trailer for road transport. They rely on the chemical coolants that we've discussed and electricity, meaning that in most cases they're constantly consuming fuel to maintain the perfect temperature and humidity conditions for the items inside the container. Reefer cooling is especially inefficient for items that respire or breathe, like plants and some fruits or vegetables, which need fresh, constantly chilled air throughout the journey. That means that hot air from outside the shipping container is continually brought in and chilled, while stagnant cold air gets expelled, or else the fruit or plants will die. As you could imagine, airless, sealed iceboxes are much more efficient, but that only works for some types of produce and pharmaceuticals. The reefer container industry is expected to grow by 7.3% per year for the next 10 years. That's almost double the total chilled logistics that we currently have in just 10 years. Harbors and warehouses around the world currently host 3 million chilled containers that look like this, but by 2030 there'll be close to 6 million of them. These containers travel on merchant vessels of different sizes, and there are about 100,000 of those ships in the world as well. So let's get into some more statistics and see how reefer transport impacts the climate as compared to standard shipping. One container carrying an average of 16 tons of load typically emits around 1 kilogram of carbon dioxide for each kilometer that the ship or truck travels. That's already a significant emissions rate, but it gets worse when the container is chilled. 16 tons of refrigerated foods release 1.29 kilograms of carbon dioxide, or the equivalent of carbon dioxide, like coolants that leak out of the container and also create a greenhouse effect that warms the planet. All in all, we're talking about 21% more emissions from refrigerated shipping than from standard temperature shipping, according to the Global Food Cold Chain Council. Remember the freezing process called vapor compression? Well, there's an innovative alternative now pioneered by a company called Rebound Technologies that uses a simple mix of water and salt to create temperature conditions as low as negative 40 degrees Fahrenheit. Another company called Dearman Tech uses liquid nitrogen to reach negative 320 degrees Fahrenheit. They've implemented that successfully in some trucks for long-haul journeys without using any HFC coolants. We use the term climate change because not everywhere on Earth is expected to get hotter due to the changes in the atmosphere. And of the places where temperatures do increase, it won't happen uniformly. Urban areas attract more heat than rural ones, and the infrastructure and unnatural topography there creates urban heat islands. The extreme temperatures in cities, alongside smog and dense pollutants, pose a serious threat to the health of the populations there. In fact, heat waves kill more people than any other extreme weather event. There's a clear equitability issue as well, in that heat disproportionately affects people of low income, living in densely packed apartment blocks without affordable AC. So let's take a look at Singapore, a city that's known for its heat and humidity, but also for its innovative and proactive government programs. The city is almost entirely constructed of concrete, and it's extremely dense. Limited land means that only the most expensive homes have gardens or access to green spaces. Since Singapore is situated near the equator, temperatures also regularly rise above 90 degrees Fahrenheit or 32 degrees Celsius. The city is a prime example of an urban heat island, with an average temperature that's a whopping 7 degrees Celsius higher than the temperatures in surrounding rural areas. The challenges of surviving Singapore's stifling heat don't apply to everyone, though. Downtown Singapore is outfitted with a state-of-the-art underground district cooling network. The network uses underground coolers and piping to connect some of the most prominent buildings in the city. Marina Bay Sands Hotel and Casino, the touristy indoor gardens by the bay, local luxury malls, and office buildings hosting multinational corporations, all cooled to 75 degrees Fahrenheit or 24 Celsius. Although that's an exorbitant temperature differential between outdoor 90 degrees and indoor 75, the district cooling network on Marina Bay is probably more sustainable than you think. The district cooling network saves 40% of energy usage compared to a traditional air conditioning system that might also be used there. In just that luxury complex of buildings, the emission savings are equivalent to removing 10,000 cars from Singapore's roads. Singapore is known as the Garden City, a nod to the Prime Minister's goal in 1967 to create a pleasant, vegetated environment that reflects the city-state's tropical location. To that end, the government plans to plant 1 million trees over 10 years, starting in 2021. The Singaporean government has also spearheaded a project called Cooling Singapore, which funds research and project developments to reduce heat in the city. Each project involved addresses at least one of 6 tenets, from increasing vegetation in streets and on buildings, to adding heat-absorbing water features, to moving natural gas facilities out of densely populated areas. These goals are ambitious and seek to cool Singapore both on the ground through shading and smart materials, and by using more renewable energy overall. Engineers estimate that Singapore could produce more than 25% of the energy it consumes just from wind and solar captured within the city limits. Singapore is also a great example of a city's power to affect wider change, and here's why. The Cooling Singapore team has programmed a proprietary technology called the Digital Urban Climate Twin, which replicates the structure of Singapore as a city and simulates the potential heat change of future design choices. For example, it can determine how wind flow would change if the city erected a row of high-rise buildings on a certain street, or how a neighborhood's average daytime temperature would change with the installation of an artificial lake to absorb heat. The most exciting thing about the Digital Urban Climate Twin is that it could soon be implemented in your city too. Singapore hopes to export the software to governments, urban planners, and developers in other cities, where increasing heat and smog is also becoming unsafe, which is unfortunately most cities. It could be a fantastic exercise in learning and implementing climate resilience, while also reducing cities' climate footprints by designing energy-free cooling solutions that don't rely on chemicals like HFCs. Before we wrap up this episode, let's explore a little more about district cooling and how cities like Singapore and Dubai use them to chill buildings more efficiently. In a district cooling system, a central plant chills the water that it supplies to a nearby customer building. It uses a series of insulated underground pipes to transport this water, and when the water arrives to the building, a heat exchanger takes the cold water, which it uses to chill the air, while another pipe system takes the hot air and hot water and returns it back to the central plant. The benefits of this and its size start with the economies of scale. It has an aggregated cooling load that helps to centralize the capital cost of chilling towers and coolers. This is not only more accessible for buildings to save money, but it also saves space that can then be used for human use instead of an HVAC system. It's also efficient because it's a closed loop of hot and cold water, and it saves energy, water, and other resources that individual building systems would burn through much more quickly. District cooling systems also reduce resource use overall by demanding less energy and water than in an individual building HVAC system. The plants also make use of 3 types of non-potable or non-drinkable water, which is more sustainable. Those 3 types are lake or ocean water, recovered gray water, and treated sewage effluent, all of which would have to go through a wastewater treatment plant anyway, and can do the trick that potable water could also do. You avoid the high costs of peak power demand on the grid when you use a district cooling system. because you have more remaining in the system to cool when the energy prices are high. Now, there's a company called Empower Energy Solutions in Dubai that operates a massive system of district cooling. The purpose is to reduce the strain on the grid, cut emissions, and also conserve energy and water. Without district cooling systems, a whopping 50 to 70% of electricity demand in Middle Eastern cities would stem from rampant air conditioning.
But architects and designers are creating new ways to keep infrastructure cool in the planet's most urbanizing and warming cities. This team of Chinese designers and architects, under the name of Insui Design, has created a solution for keeping public transit tunnels naturally chilled for passengers on hot summer days. They've employed one of the world's most insulating natural materials, terracotta. This is a building material seen on the outside of homes and buildings in tropical and desert regions, thanks to its natural insulation properties. Insui Design's terracotta concept takes insulation a step further. They plan to install tiles that harness the moving air from passing trains, cooling that air with reused water that runs through the walls of the subway tunnel behind the terracotta tiles. As the world moves away from carbon-intensive cars and toward public transit in underground tunnels, solutions like terracotta wind could create energy-free cooling solutions similar to the architectural strategies we observed from the ancient Middle East earlier in today's video.
Cooling the world is such an important part of living in the modern day. It's critical for public health and productivity, but it also contributes so dramatically to climate change. How can we progress as people, and as people with the comforts we've known to live with, without causing irreversible harm for future generations? Well, there are certain notable innovations we've talked about today, like district cooling and alternative coolants for reefers that don't leak harmful fluorinated gases. The pharmaceutical space also calls into question some of the most pressing cold chain challenges, especially because of how vital medicines and vaccines are to communities that are far from cold chain infrastructure. Can our warehouses, grocery stores, and hospitals in the developing world tolerate power blackouts or brownouts? Will there be enough power and sustainable power to meet the demand of our cold chain system to feed and keep people healthy? Will cold chains also be able to rely on an all-renewable power purchase agreement that today at least use inconsistent power sources without strong underlying battery systems to stabilize the readily available supply of energy? All of these things lead us to ask not only how cooling affects the climate negatively, but also how we can use it to make humanity stronger and more prosperous, not only today, but for future generations, which is always the modus operandi on this channel here. So thanks for watching. Again, today we talked about cooling the planet and how that contributes to the warming planet. We talked about shipping, cold storage, the cold chain of pharmaceuticals and food, keeping our cities cool in highly efficient ways, as in Singapore and Dubai. And in the future, I encourage you to go on thinking about this when you enter a cold coffee shop on the street, or when you crank your thermostat down as the summer heat rises in the next few weeks. Thanks so much for watching, everyone. Next time, we'll be here talking about yet another climate change related topic here on Planet Watch. Bye for now.